Thank you very much. Oh, thank you very much. Ladies and gentlemen, thank you. Can we have the first slide up? This is a mixture of PowerPoint and pickies, and then switching between that and DCP. So if we can have the slides up, and then I'll say, could we run the DCP, please, Russ? And then we'll go and watch some footage. So I'm Phil Streather, and this is
Caroline Hawkins, and I'm executive producer at Oxford Scientific Films and the producer of Meerkats 3D.
So the way we're going to structure this, if you guys are happy, is that we've got about 45 minutes. I'm going to do an introduction, a little bit of 3D basics, just so that I'm comfortable that you guys have got my particular orthodoxy on board, and just recap if there's any little technical basics that you might not have picked up over the last day and a half, and then we'll segue pretty neatly and quickly into looking at the whole Meerkat project and how that gestated, where it came from, and what's happening. So Caroline will hop off for a sec. You can take the lights quite significantly down on me, please. So I don't. How many of you here were watching the post-production session yesterday with Dado Valentic, and have therefore actually seen my? So not probably only a fraction. Well, that's good. Phew. So I'm a 3D film producer. I've been doing it for not quite longer than I care to mention, but sort of heading that way. I've been doing it for sort of over 10 years now. A film that I guess most well known for was that Bugs movie, an IMAX movie which is still playing at the BFI and the London Science Museum. But since then, and I'm delighted to say that of all these projects, apart from the Sky 3D one, which was Caro, I have my new favourite director with me. Mike Slee directed the Bug movie, but Julian Napier, who's down here in the audience in the front second row there, was the director of Starlight Express. That was 3 two-minute movies for a live show that Julian conceived and directed of those clips. I was executive producer on that. I produced and Julian directed the London I-40 Experience, a little 4-minute movie which plays to everybody who goes in front of, I know, 75% of people who go to watch go on the London Eye, who fly the Eye. And most recently, Carmen in 3D, which again Julian directed and I produced. For Real D in the Royal Opera House. That's our latest one. That's going to be going live to about 1,500 theatres. Not live, it's a movie, so it's going to open in 1,500 theatres on beginning March the 4th. And is going to be the closing gala film at the Santa Barbara International Film Festival in the beginning of Feb. So I'm very pleased about that. So that's sort of IMAX to special venue to cinema, and then down at the bottom right here, this is television, obviously. And I've palled up with Oxford Scientific Films because of my wildlife background and 3D background, and we are co-producing the Meerkats 3D film for Sky. What I just wanted to do was just do a very little basic recap as to the various types of 3D that there are, of which I have then the multiple examples in the clip reel that I'm gonna show you. But I just wanted to make sure that everybody understands what parallax is, and when people say the screen plane, what's that? And when people talk about negative parallax, what does that mean? And on screen, where are those images, so that we can, and what does depth budget mean? What are they talking about when they're talking about depth budget? I mean, forgive me if, or is that so passé that you know all of that? Does everybody know all of that, or shall I just whiz through it? Whiz through it, okay. So what you've got, obviously what defines a 2D film from a 3D film is the fact that on screen you've got 2 images. Now those 2 images have a separation, and that separation is called parallax. Those parallaxes get divided up into basically negative parallax. If there is no separation between a part of the image, then that is called 0 parallax. Obviously, if the entire image has 0 parallax, then it's effectively a 2D image. But what tends to happen is that there is a point in any one 3D image where there is 0 parallax, which is where the 2 images effectively overlay. And then there is positive parallax. Now, positive parallax is the parallax which is behind the screen. It looks like you could put your hand into the screen, walk through the screen, looking out of a window, etc. And on screen what's going on is that the left eye image is over to the left-hand side of the right eye image, and your eyes are focusing pretty much on the screen, but instead of seeing two images overlaid here, you've got a little left image here and a little right image there, and the brain interprets that to think, okay, I'm going to fuse that. It's obviously the same image. I'm looking at a ball for the sake of argument. It's obviously the same image. There must only be one ball. I will make my eyes now move so that the brain sees only one ball. And the fact that the left image is on the left and the right on the left, the brain puts the ball behind the screen. If you've got two balls exactly overlaid, in terms of where that ball is placed in space, that ball will appear to be on the screen. Now, if you've shot it with a certain width between the cameras, a certain I/O, which is your volume control on 3D, then obviously that ball is not going to look like a 2D ball. It's going to still have a nice bit of roundness and look like a 3D ball. It's just that's where it's placed in space. Because, of course, in 3D, you've got these three axes now. You've got your y-axis, which is up and down, and your x-axis, which is side to side, and that's what you have in 2D. But the 3D adds the z-axis, which is the going back into the screen and coming out of the screen. That's your z-axis. So when you've got zero parallax, if we have a nice 3D shot, it doesn't mean it's flat. So if something's on the screen plane, it doesn't mean it's flat. It just means that's where it is in space. It just means this lovely ball that could have all sorts of roundnesses here, rather than 20 foot behind the screen or 100 foot behind the screen, or indeed sitting anywhere in audience space. So that's zero parallax. Negative parallax seems to be the thing that's really got people going in this 3D game. You know, some people call it a gimmick, some people don't like it at all. Many films right now are not using any negative parallax at all, arguably therefore becoming 2.5D rather than being 3D. Negative parallax is when something, any object at all, is effectively in audience space. Now, in order to achieve that, the images on screen are reversed from positive parallax. So now the left eye image is actually over to the right-hand side of the right image. And thus, with the glasses on, which mean each eye is only allowed to see the image that's designed for it, in order to actually fuse ball right, ball left into a single ball somewhere, the eyes have to cross over, and they relative to the screen. And the brain then interprets that as the ball now being in front of the screen and in theatre space. And that is negative parallax. If you have something at positive parallax, but the distance between the images on screen is 2.5 inches, then that is called stereo infinity. That means that that object will appear to be as far behind the screen as it ever can be. But there's a big caveat. 2.5 inches is what our eyes are, and our eyes basically stay parallel. And a number of people may say, oh, you can't possibly ever have any positive parallax beyond 2.5 inches because our eyes aren't designed to do that. Well, on the one hand, it's true, as in our eyes aren't designed to do that. But on the other hand, our eyes are extremely flexible, and we're very flexible, and we're very adaptable, and we can actually bend our eyes out to about 1 degree per eye, allowing for a much greater sense of depth in the screen. If you make your positive parallax greater than 2.5 inches, it makes it feel things are further away than you have ever seen them. Something that you can use creatively, something you can use for a storytelling point, is enhance the depth, make it not look natural, but exaggerate it. So that gives you, therefore, your negative parallax, gives you your off-the-screen moments. If people talk about stuff happening at the screen plane, it means that the cameras are converged, as in the angle between the cameras is such that the light beams cross over, and wherever they cross over, by definition, there's effectively an overlaid image. That will end up on the screen plane. And then there is behind the screen, into the screen, which is positive parallax. Everybody happy with that? Any questions on that? Okay. So, yes, sir. Apart from people who are real experts like Ran.
Yeah. So
what's up, dude?
By your diagram, the screen, what you call the screen plane is where the convergence point is.
Yes.
So where, on the left example, where you see left and right eye, so essentially the convergence point is where it says screen.
Well, this is eyes. This isn't cameras.
Exactly.
These aren't cameras.
Yes, that's
these
what
are
I want
eyes.
to clear. So
yeah.
So
sorry, left eye, right eye.
Left eye and right
this
eye.
Is audience. This is audience, not camera.
Thank you.
Okay, sorry. Good point. Thank you very much, Ran. Okay, what I want to do now, in just one sec, I just want to show the clip reel. It's got a very wide variety of 3D stuff in this. Ranging from stuff that was shot from IMAX. The irony is, everybody thinks IMAX, oh, massive 3D, huge 3D, everything hugely in your face and sitting on the end of your nose. The first shot in this reel is from an IMAX movie. It looks fantastic on IMAX. I think it looks great on this screen. It looks great on a small monitor. So anyone who tells you, oh, you have to do things totally differently per every screen, I'm happy to say that this is living proof that that's not the case. There are other shots from Bugs where there's a lot more 3D in it. Again, it's an IMAX movie. It exists in the digital realm, and it's currently playing on Sky Television, on Sky 3D, and people are loving it. So again, you can absolutely repurpose your material across multiple formats. But I will say that the range of 3D in this ranges from what one might expect in a theatrical experience, a regular cinema experience, right up to big in-your-face 3D, which is an expectation really when you make attraction movies or theme park movies or short-form movies, where the absolute expectation of the audience, and they probably ask for their money back if they're not hit in the face with something, reaching out for something, the kiddies are squeaking and everyone's having fun. That is what one calls gimmick 3D. My argument would be that for that to be called real gimmick 3D, it has to be pretty extreme negative parallax. And I'll follow up on that shot, on that idea when we look at some stills from this clip reel in just a second. So in the meantime, just put your specs on, huge range of 3D, some of it's in your face, some of it's cautious, and then we can have a chat about it in a sec. Huge thanks to Julian Napier, who's the director of a big section of that content. Shot on a multiple of systems from film. All the bug stuff was all shot on film, from Red 1s to D21s, the Arri D21, even some EX3. And most of that Gladiator stuff was shot on the little humble Sony EX3. So 3D does not have to be expensive, but you do have to have a certain level of camera quality and rig to be able to pull it off. Let's see if we can therefore just derive a few very useful rules of thumb. Obviously, 3D is not painting by numbers, but there are a lot of numbers involved in painting 3D. So you can reduce certain elements of 3D to numbers and rules and regs, and you have to. It's a bit like anything. You know, there are depth of field charts. You know, there are latitude charts. You know, cinematography and movie making is full of numbers everywhere along the line. Anyone who says, oh, you shouldn't be doing any 3D by the numbers, I'd posit they aren't particularly involved in the actual physical process of making film themselves, which is all about numbers.